right, well, while people are still coming in, I wanted to go ahead and start on time. So I'll go ahead and do some quick announcements and then introduce our speakers. So my name is Jasmine, and I am the meetings coordinator for AAS. I want to remind you all that this session is being recorded. You'll be able to access it within 24 hours, and then as well as for 30 days after the whole conference concludes. If you want to ask questions, we'll have time for that at the 15-minute mark, so about 4:15 after the presentation. Feel free to unmute yourself or ask your questions in the chat box. And with that, I can introduce our speakers for this evening. So we have Brian Miller, Andrew Stevens, and Arturo Nunes. I hope I said that right, from NOIRLab.
Okay, thank you very much. I guess we have multiple options for entering questions, either in the chat feature of the Zoom or in the thread in Slack. There's the link to a thread in Slack if you want to screen copy that quickly. We'll get right into the introduction. A brief background on Gemini in case you're not familiar with it. The International Gemini Observatory runs twin 8-meter telescopes, one in Hawaii and one in Chile, giving full sky coverage. In addition, there's a 6-hour difference in longitude, which may be of use for time domain follow-up activities. Gemini's international partnership, 5 full participants, 2 hosts, Chile and Hawaii, and various exchange partners, the US having the largest share at about 67%. We have complementary optical and near-infrared instrumentation. The optical is almost identical, at least with GMOSs. The facility instruments that we have are well integrated into the entire system. Visitor instruments have come and go in various durations and communicate with the telescope via some APIs. So we've been in operations for 20 years and been using mostly the same operations software that's been evolving with time. We've made a variety of improvements to it, including automatic guide stars, including like arc and flat lamp configurations into the OT, included the ITC. But there are a lot of changes that we want or need to make that cannot be done with the current software. Therefore, we've embarked on an ambitious program of projects called the OCS upgrades that will replace most of the high-level software. And the Gemini program platform, GPP, which is kind of the focus of today, is the core project in this, which will develop a new, basically, phase 1 tool or PIT and observing tool. So it's going to consist of several web applications connecting to a single database. And here's a list of a few of the tools that you may use in the future. There's a dashboard, which is sort of where you start out. You get access to all of your programs and proposals, see notifications of status, probably a way to communicate with the observatory or your contact scientists. Explore is the core of what we're focusing on today. It's going to be the replacement for the PIT and OT, so it's proposal and observation preparation. Chronicle is for logging, so you can see what happened, and we'll use it for quality assessment, time accounting. And Browse will be a search feature. And there'll be various other apps that we make for internal use for operations. So the GPP OCS upgrades will hopefully address the limitations in the current system. Our concept is it will automatically create full executable observations, valid observations. So if you can use the standard settings, basically there's no phase 2, it's all done for you. The ITC will be fully integrated, so you can use it to set the exposure times on observations. Related calibration observations such as telluric standards or PSF standards will be automatically created based on rules and configured the same way as the science observations that they come from, so there can't be a mismatch between them. There'll be a single database, so programs can contain observations from both Gemini North and South, so it's easy to switch between the two or use whatever site is most appropriate for an observation. That gives us more flexibility for finishing programs. If you can use the standard set automatically created observations, then There's no need for any manual checking such as we do now, so that reduces staff work as well as gets things on the telescope more rapidly. There's going to be an automatic real-time scheduler, which will allow a lot more flexibility at night to reacting to different things that happen, like weather changes, TOOs, any faults. So it will make our operations more efficient. There'll also be a much more capable suite of APIs for programmatic access, which will be compatible with various follow-up networks that we are involved in. And in terms of process, we'll be doing continuous integration and deployment with a standard database infrastructure based on Postgres, which will make changes much faster, be much more easy to do bug fixes and release new features than we have now with about a 6-month release cycle. Also, because it's a web-based architecture, independent of operating a system, there'll no longer be large applications to download and install every 3 to 6 months. So with that, we're going to go on to a overview of the Explore app.
All right. So thank you, Brian. So let's start out with a quick look at the layout of Explore. So at the top, we have our Create Proposal button. Over here in the middle top, we have this application switcher, which is going to allow the user to navigate between all of those applications that Brian had mentioned: Explore and Browse, Chronicle, Dashboard, Weather, everything like that. The user identity is in the top right. You can see right now we're actually using anonymously, but this is where you would go ahead to authenticate, and we're going to use ORCID for that. On the left are these vertical navigation buttons. These provide views of the proposal and observations, and I'll go through and show what those look like. The item tree just lists all of the observations or targets or configurations, depending on which view you are using. And then all the details are shown in the right. So let's go ahead and we'll click on this observations view here. Maybe. There we go. So the observation view gives you all the important information of your proposal and your observations in a single place without having to click around to find things. So all the observations are displayed on the left, and then all of the target details, the constraints, little lag, the instrument configuration and the ITC results are over on the right. So let's go ahead and just zoom in here on the target component. There we go. So what we see here is this is where you either go to select or define your target. You can start by setting the target type, sidereal or non-sidereal, and then you can either manually enter your coordinates or manually upload an ephemeris, or we can search SIMBAD or horizons for known objects. We have the target morphology and your spectral energy distribution here so that we can feed the integration time calculator. And then over on the right, we have the field visualizer, which we're currently pulling from Aladdin Light. Let's go ahead and look at the next panel down. That's the constraints panel. So this is just where you select the worst allowed conditions, the image quality, extinction, everything, including your timing windows. Let's go then to the next panel down. That's the configuration panel. So this allows you to describe what you need at the highest level without requiring detailed knowledge of all of Gemini's instrumentation and those of our exchange partners. So basically you enter a few high-level things like I want spectroscopy and I want a resolution of 1600. And then over on the right, it's going to automatically give you this list of all the matching configurations, modes, instruments that will meet those requirements. You can go ahead and add additional constraints over here on the left, and you will refine that list of matching configurations on the right. The last thing I want to point out over here on the right, we're going to be running the integration time calculator in real time, so you will actually be able to see exactly how much time you need for each of those configurations to achieve the signal to noise that you requested for your target that you have defined. So at this point, we have basically, you've inputted all the information you need. As Brian said, we're going to automatically generate the sequences. However, if you are adventurous, you can go ahead and click on this advanced configuration button right here. I'll go ahead and click it. And this allows you to configure all the instrument details. You can go ahead and modify the input parameters that go into the automatic sequence generation, like your wavelength dithers, like your spatial offsets over here. By default, we're going to calculate exposure time based on the signal to noise. But if you don't want to do that, you can change that here. You can instead say, I want a fixed exposure time, or I want a fixed number of exposures. So now let's go ahead and look at that last panel on the observation panel. It's the ITC panel. And this is the ITC. It's basically taking all of those target parameters, all of the constraints that you set, all of the instrument configuration, and it's giving you in real time the signal to noise that you can expect. And this gives real-time feedback to the user on how the instrument configuration and how these constraints affect the signal to noise and thereby affect the total time required to achieve that signal to noise. The last thing I want to show on that observation view is the observation list. This was that list over on the left-hand side. I've now pushed it over to the right. The things I want to show here are, first of all, you will see that we have calibrations. For example, here are some daytime arcs, things like daytime darks. Down here, we see some telluric standards. These are linked to the science observations. That means they will always match. So if you go and you change your science configuration, you don't have to worry about making sure that your daytime calibrations or your nighttime standards have the same setting. It's all kept in line for you. The other thing is we're going to support logical groupings, meaning and or groups. So here you can see we have an or group set up with 2 observations inside of it, and then the scheduler takes care of it. The other thing I want to point out is we're going to support mixed Gemini North and Gemini South observations. So this OR group actually includes a GMOS North observation and a GMOS South observation. So the scheduler will take care of it. It will schedule whichever one fits into the queue the best, or if it is a time critical observation, it will schedule it on whichever telescope can respond the fastest. So that was our observations view. So let's go ahead and click on the targets view down here next. And so the targets view, the targets view is provides a different view on the same information. So here everything is organized by target. So this means that it is easy to see which observations you have of which target. It's easy to drag observations between targets, to duplicate observations for different targets, to import massive target lists and copy the same observation onto that massive target list. And what's really nice is if you elected to use signal to noise as the way that the exposure times are calculated, then if you drag a fainter target drag an observation into a fainter target, that is going to yield a longer observation. Or if it is a brighter target, it will yield a shorter observation. And likewise, if you have multiple observations of the same target, if you go and update those target parameters, that updates all the observations of that target. So let's go ahead and we'll just quickly show what the constraints view looks like here. So this is the same sort of thing, except now everything is grouped by constraints. So here we can see we have good seeing and dark, good seeing and bright, poor seeing and gray. So again, it makes it clear what you're using, and it makes it simple to edit the constraints for groups of observations or to import groups of timing windows that apply to single or groups of observations. And then lastly, I'll just go ahead and I'll click on this configurations view right here. So we have the same idea, except now everything is grouped by configuration. So we can see we have a GMOS North configuration, a GMOS South configuration, and a GNears configuration. And we can just drag, in this case, drag things between the different configurations, and everything takes care of itself. So everything we have done up until this point, we have been anonymous. We have not authenticated. And the great thing is this allows anyone in the world to try out Explore, and we're hoping that this will also allow anyone in the world to try out Gemini. However, if we want to go and create a proposal, we're going to have to authenticate. So we would click up here. We're going to authenticate through ORCID. And then that allows us to then click this Create Proposal button. So I'll go ahead and do that. And then we are taken to the proposal view. And then what we see is we now have a new view that was not here before. And the proposal view, this just allows entering all of your investigator details. Type in your abstract. One cool thing about the proposal view, since this is a web application, we're going to allow sharing your proposal with all of your collaborators. So you can elect right here which proposals can read, which can edit, and you can even designate collaborators to have submit privileges. We're going to have just a PDF summary of the final proposal here. And then down at the bottom are buttons for downloading your template, which includes the science justification, the technical justification, and that's different for some partners, and it's different for different proposal types. There's also a button for sharing with non-collaborators, exporting, duplicating, and then finally over on the right for submitting our proposal. So let's go ahead and we will submit that proposal. And after we've done that, it basically looks the same, except now everything is going to be not editable. However, we will notice down here at the bottom that submit button has changed into a retract button. So after we submit, we're designated a unique proposal identification. An email is sent. And if you want to make changes, you just go ahead and click on this retract proposal button. You can make all the changes you want. You can then resubmit, and you retain that same proposal identification. All right, so I think, Brian, it is back to you. And you were muted.
I was, yes. It was a hard time getting back to the button. Okay, here we are. So everything that you've seen is in the GUIs can be done with programmatically with APIs, because the GUIs are just front ends to these application interfaces. And we'll be using GraphQL for the query structures. And this is a bit different from the REST frameworks that a lot of APIs use these days, which is like a URL endpoint. Use of GraphQL allows for more flexible queries, and you just get the data back that you're interested in. This is going to require a little bit of learning curve, some training, so we'll provide some aid, perhaps defining some common queries within, say, some Python libraries. So you just need to fill in the parameters of the query, kind of like you do now, and not have to worry about the GraphQL structure. And we'll provide examples of GraphQL so you can make your own sophisticated queries. So now we do this. The Explorer is now under development, and Andy will lead us through a tour of the new version.
Yeah, so go ahead and click run on this demo. I wanted to do it live, but I did it live last night and recorded it. So here's the login screen. So we can either choose to log in with ORCID, as I mentioned, or we can continue as guest. And if we continue as guest, we see we're an anonymous user up here. But let's go ahead and let's try the ORCID login just to see what that looks like. I'm not logged into ORCID, so I have to first sign in to ORCID. And if this is the first time you've ever used Explore, ORCID is going to ask you to authorize Gemini to access your public ORCID information. So I'll go ahead and let's do that now. So now we can see in the upper right, I am indeed logged in. And over on the left, we see all of these navigation view buttons that I had showed in the demo. Let's go ahead and click on this proposal button. So here we see our initial state. We can enter a catchy title. We can enter the proposal class. We'll just say cube observing with Gemini. Next is the category. I'm going to go ahead and select stars and stellar evolution. The keyword list is quite long, as you can see here. So why don't we just go ahead and type into this box. We can go ahead and type stellar, and there it matches stellar populations. And we can actually start to type in abundances, and it will match chemical abundances. and we don't need any TOO activation for this proposal. Now over on the left, the times here are the sum of the observations we have already set up. But here we can see that we need to designate our partner allocation. So let's just go ahead and say it's 50% Canada and 50% US. So now we can go back and we see indeed, we see two partners, 50% split, and we see that the total time is now split evenly between those two partners. We see over here is a minimum percentage. We'll just leave that at 80%. That's the minimum to be scientifically useful. The overview is still in progress, as we see here. The observation view, this is really an aggregation of all the information. So this is something we're going to continue working on later. The targets view, this shows all of our targets here on the left. And if we click on them, we can see the target details in the middle, and then we can see the Aladdin Light preview over on the right. If I go over here and move around, we can see the cursor coordinates are shown in the bottom right, and then we can see the size of that field of view is shown in the bottom left. I can click on the magnifying buttons to zoom in, and then of course I can use the scroll wheel to zoom back out. Now let's go ahead and try adding a new target. So there's a plus button over here in the upper left. Go ahead and click that, and I can add now my target details manually. So I'll go ahead and just make a new target, and I'll just go ahead and let's say RA of 111 and the deck of 111. Now I guess, and we have started to include data entry validation as well. Make that 111. Go ahead and enter that, and then we'll see the field update on the right. Not much there. We've also started to implement undo and redo. So just to demonstrate that, I'm going to go ahead and type into the epoch field here, and I'll just type a couple of values. So we'll make it 2001, 2, 3, 4. Go ahead. Now if I go down here and click undo, we can see that epoch go back through each of those edits, and I can actually click on the redo button as well, and we'll take us back to through all those steps that I had entered. So let's go ahead and we can actually type in a name target. Let's try something like Hipparcos 1, 2, 3, 4. Click on the magnifying glass. That will query Simbad. It will grab all of the motion details and populate them, and grab all of the magnitude information and populate those as well. So we currently have 0 observations of our new target. We can see that here. We can see our other targets rather, had 2 observations each. So let's just go ahead and we'll grab an observation and we'll put it down here in our Hipparcos star. And let's go ahead and grab another observation and drag that on down. So now we can see we have 2 observations of our Hipparcos star. The remaining 2 views on the bottom left are still in progress. So that is the end of the demonstration. So back to you, Brian.
Thank you. Need to stop this. There. So as you see, it's under development. It's still fairly early stages. We are working towards a system that supports GMOS North and South imaging and long slit by May 2022, when we hope to issue a call for proposals for early science testing. We're calling it the XT phase. Over the next year or so, where we continue with testing and early science, as well as continuing the development, every few months rolling out new support for new instruments and new modes, so that we are in full operations by the start of 2024A. This gives a little timeline of the development of GPP along with other related projects and programs. So in summary, OCS upgrades in GPP will make the use of Gemini easier and more efficient for everybody, improving the things that are mentioned here. And I said it's early times, and we're interested in feedback and comments and involvement from the community to make this the best software possible that'll be the most useful for you. So you can get information and provide feedback at this URL here. from the Gemini web pages, or you can contact Andy or myself. We'll probably be reaching out specifically in the coming year for early testers. So now we can, I think, open it up for any questions.
All righty, feel free to unmute yourself or ask the questions in the chat box and I'll read them out loud. Okay, Lisa.
Hey, Brian. It's really a really nice demo, particularly like your the proposal tool. For the specifying the observations and all the instrument parameters, is that functionality, I guess, available through an API as well? In terms of I guess, is that how the TOMs currently work? Is put together all that stuff, but this is a web-based tool that you'll be able to do it more easily. I mean, and also I thought that was really nice, the an or in terms of or for which facility. That's a really nice feature to add.
Andy, do you want to take that?
Yeah, absolutely. So the idea is that the APIs can do everything. It will basically be the same way that the web application communicates with the database. All that functionality should be available to end users.
It's just really impressive. I particularly like the submit and then retract without having to do anything.
That and undo were two of our most requested features.
Oh yeah, no, it's fabulous. Yeah.
All righty, I have a question from Warren who has his hand raised.
Hello, folks. It was nice to see how the exposure time calculator sort of integrated in. Could you say anything about any? I'm thinking about real-time decision making. If the signal to noise in the observation is lower than expected for whatever reason, could you say anything about how real-time decision making, providing some information to the service observer, perhaps might be incorporated into the tool that you're developing?
I'll go ahead and you can then correct me, Brian. So there's a lot of work that we have yet to do on that. That's as you allude to, that is a really complex problem. There's a lot of information coming from weather monitors, from the our real-time data processing that's going on, from satellite imaging, from forecasts, from our guide probes that give us a rough estimate of the seeing and the extinction. The idea is that we're going to try to aggregate as much of this as possible and give the observers, the nighttime staff, the ability to supplement that with what they are seeing that we could not automatically aggregate. And then that will be provided as a service to the queue scheduler. And then the observer will basically be prompted with, here is what the queue scheduler recommends that you do. And the queue scheduler has the option of rejecting that suggestion, but assuming we can get all the information to the queue scheduler, we're hoping that suggestion will be the best one.
Okay, thanks very much.
Yeah, and sorry, I skipped over your signal to noise, your original signal to noise question. That's probably a later phase. We are going, as Brian mentioned, we will be dynamically generating the observation sequences. So you may have requested, I would like better than 1 arcsecond for my observation, and when you write your proposal, it will automatically generate a sequence, assuming it is executed under 1 arcsecond seeing, or slightly better. However, when it actually gets scheduled at night, the seeing will be better than 1. It may be 0.8, it may be 0.7. And the idea is that that then is fed into the ITC, which says, okay, this is how long the sequence should actually be. So it likely will not be what you saw in your proposal. It will likely be shorter, so that it does deliver the signal to noise you need.
Okay, yeah, you started talking about, because I don't know, probably it's more important for TOO type programs where the brightness of the target may be higher. But clearly you're thinking about this, so I don't need to worry. So I'm confident. Thanks very much.
Your confidence is appreciated.
All righty. I see Josh has a question, but unfortunately we have ran out of time. So Josh, please put your question in the Slack channel and we'll make sure it gets answered for you. Thank you, gentlemen, for your presentation. If anyone wants to watch this recording, it'll be available within 24 hours. So with that, have a good rest of the evening.
All right, thank you.
Thank you.
You.